Hi everybody, it's Mr. Oaks. So we're going to start talking about scientific notation. Now scientific notation is a way for us to show very large or very small numbers, to basically write them in a way so that we're not writing just numbers upon numbers. We usually are going to estimate the number to a certain point, usually to the nearest hundreds place. Depending on whether it's a very large or very small number, basically to two decimal places. And then rewrite it so that we have two parts. Scientific notation has two parts. The first part is always a number that is either greater than or equal to 1 or less than 10. So as we look at these two examples, I have a 5.3 here, I have a 7.12, this decimal a little clearer, and the second one. Both of those numbers are between 1 and 10. We can have 1, but we can't have 10. So we could have 1 times, and then the second part is a power of 10. So 10 to some exponent. 10 to some exponent. So that exponent could be positive or negative. A positive exponent we're going to use when we need to represent very large numbers. And when I say large, I mean anything that's 1 or greater. And when we have a negative exponent, we're representing a small number, which is basically any number between 0 and 1, a decimal number. Okay? So as we see, 5.3 times 10 to the 7th. This is a very large number because it has a power of 10 that is a positive exponent. 7.12 times 10 to the negative 4th. This is a very small number. This number, when I convert it, is 53 million. Now I did that very quickly, but I'll show us in a minute how we can actually do that. 7.12 times 10 to the negative 4 is actually this number. So you see it's a very small number. It's between 0 and 1. So converting numbers to scientific notation from what we call standard notation is actually not that difficult. When we are looking at a number, we always have to basically ask, where is the decimal? In the case of our larger numbers, most of the time there's no decimal to be seen. What we have to realize is that any number we see, especially what's considered a whole number, has a decimal at the end. So here are two large numbers, 65 and 5,400,000. When I look, I don't see a decimal there. What I have to do in the case of 65 is I have to put a decimal at the end. Okay? So now I have 65 with a decimal afterwards. And all I have to do is move that decimal until I get a number that's between 1 and 10. Now in this case, I wouldn't move it to the right because it would just get bigger and bigger and bigger. What I have to do is move that decimal to the left. And in this case, I'm going to move it only one place, in between the 6 and the 5. So now I have my number between 1 and 10. 6.5. I'm going to multiply that by a power of 10. So I'm just going to automatically write 10 there. Now I just have to put the power. What I'm going to do to figure out the power is I'm just going to count how many times I move that decimal. I moved it to the left one place. So that's my exponent, a 1. What I like to do sometimes to kind of help me out is to kind of make what's called a template. And what I do when I make a template is I know that when I have I have to write a number in scientific notation, I know I need a power of, a number that's between 1 and 10, so that's the number that goes here. I know I'm going to be multiplying it by a power of 10, and that power of 10, the exponent's going to go right there, okay? So what I do is I then go and I look and I say, okay, well, what's my number between 1 and 10? Here again, I have 5,400,000. I don't see a decimal there, so I'm going to put a decimal after that last zero, right at the end. And then I'm just going to start moving that decimal either left or right in order to see whether I can get a number between 1 and 10. So when I look at this, I'm going to just start moving it. 1, that's not yet. 2, right in between the 5 and the 4. You'll notice that we're going to have a number directly to the left. We're always going to have one more number to the left of the decimal. So now I look, I go, oh, I got 5.4. I don't need to write all these zeros. The zeros aren't going to affect my answer, so I can just write 5.4. Now what I need is I need to know, well, how many times did I move that decimal? So I look, I got move it once, twice, 3, 4, 5, 6 times. I moved it 6 times, so I'm going to put a 6 for my exponent, okay? And that's it. I've written a number, a large number in scientific notation. Not very difficult. When we have very small numbers, we're going to do the same thing, okay? We're just going to see, I got to move the decimal so that I have a number between 1 and 10, and then how many times did I move that decimal? It's just that now we're going to have an exponent that's negative because we have a very small number. So starting here, I look, I have a decimal, so I don't even have to draw the decimal in, it's already there. But I do have to start moving it so that I get a number between 1 and 10. So I'm going to take it and I'm going to move it. Now most students stop here. They look, they say, oh, here's a number that's between 1 and 10, and they stop here. And what you have to realize is, I need this decimal behind the first non-zero number I come across, in this case 2. So I actually have to move it one more spot. Okay? So my number is going to be a 2, and I could put 2.0, but I don't really have to. Times 10, and now I need my exponent. Well, first off, I got to remember, this is a very small number, and very small numbers have negative exponents for their powers of 10. So I have to write that negative down. Now I can start counting. I moved it 1, 2, 3, 4, 5, 6 places. So this is 2 times 10 to the negative 6. Not bad. Here's one, and notice, oh, we got more than one number over here. I'm going to still do the same thing. I'm going to go, I already have a decimal right there, I'll make it a little larger, and I'm just going to move that until I have one non-zero number to the left of the decimal. So 1, 2, 3, it goes between the 2 and the 1. I'm not going to keep going. I don't want all those numbers to the left. I just want one of them, the 2. So I'm going to put my decimal there. So my number between 1 and 10 is 2.16. Okay? I don't have a lot of numbers after it, so that's good. I do kind of want to try to use as many as I can, but usually that first number, we're usually only going to have 2 decimal places after. So we might have to round in order to get it down to 2 decimal places. And that's usually what we call estimating. We're going to estimate for scientific notation so that we don't have this long string of numbers after the decimal. Times 10, and then I just look again. Well, what did I do? How many times did I move this? Well, first, it's a small number, so a negative exponent. 1, 2, 3. We moved it 4 times, so it's times 10 to the negative 4. Not too bad. Okay. Well, we changed from what's called standard notation. Standard notation are the numbers that we usually see, to scientific notation. But now we're going to go the opposite way. We're going to go and convert from scientific notation to standard notation. So basically what we're going to do is we're going to go in reverse of what we've been doing. We're going to look and we're going to say, well, what is my number that's between 1 and 10? In this case, it's 2. So I'm going to write that down. I'm going to see, is there a decimal that I see? No. I'm going to put one right after that 2, though. I'm going to do it in this red. It's kind of magenta. Okay? And then I'm going to look at the exponent. I'm going to see, is it telling me I have a big number or a small number? That's a positive exponent. That's a positive 5. That means it's going to get bigger. So I'm going to go and I'm going to count. I'm going to go, okay, well, here's my decimal. I'm going to start just kind of swooping to the right in this case to give myself, well, how many times do I move this decimal? 1, 2, 3, 4, 5. I put the decimal there. And you'll notice I have all these swoops, but there's nothing there. So I'm just going to fill in. And every blank swoop, I'm going to put a 0 in. So there's a 0, 0, 0, 0, 0. And just so I don't have it all messy with the swoops and the extra decimals over it, I'm going to rewrite it. 1, 2, 3. And I don't have to, but I'm going to put the comma there. So 2 times 10 to the 5th is the same as 200,000. Alright, this next one is a little tough to see, but that's a 171. So I have 1.71 times 10 to the 4th. So I'm going to start by writing that decimal, that number between 1 and 10 down. 1.71. And then I'm going to look and I'm going to say, okay, well, I have to move that decimal how many times? My exponent says 4 times. So I'm going to go, and it's a big number, so I got to move it to the right now. I need to make the 1.71 bigger. So I'm going to go 1, 2, 3, 4. So here's the new spot for my decimal. Now notice, there's 2 spots already filled by the 7 and the 1. 2 swoops already filled by the 7 and the 1. So I only need to put 2 more zeros. 1, 2. The reason I want to point that out, and we have, first off, 1, 7, 1, 0, 0. So we get 1.71 times 10 to the 4th is 17,100. Reason why I want to point that out is because the biggest mistake most students make is that instead of counting the number of decimal places, they just throw that number of zeros. So even though here we wound up with 5 zeros, that's not because we're just throwing 5 zeros down. We have 5 zeros because we had to move the decimal place 5 places and fill in those spaces with zeros. Here, I'm not throwing just 4 zeros on the end there. I'm moving the decimal place 4 times and then filling in any extra space with zeros. So in this case, I moved it 4 times, but I only have 2 zeros. So watch out for that mistake. Okay? Here, 5 times 10 to the negative 3. Make that negative a little more noticeable. So again, I'm going to do the same thing I've been doing. I'm going to start off by writing down the number that's between 1 and 10. In this case, it's 5. I need to put a decimal there because there's no decimal. So I have to put it directly to the right of the 5, directly to the right of the number. And then we need to move it. This is a negative exponent, so in order for us to write this number properly, I have to move that decimal now to the left because I need to make it smaller. So I'm going to move this decimal 3 places to the left. And you'll notice the negative is on the left-hand side, so I'm going to move it 1, 2, 3. So my decimal is going to go there. And again, notice, one of the spots is filled by a 5. I only have to put 2 zeros. Now, the smaller numbers are a little bit different because we kind of can cheat a little bit and say, yeah, it has the same number of zeros as the exponent. Because if I put a 0 to the left of the decimal and then put what I've written, I do have 3 zeros. I still don't want to fall into that trap though, because if I get used to being like, well, I can just put the same number of zeros as the exponent, I'm going to lose the fact that what I'm really doing is moving the decimal place the number of times that the exponent is. Okay, so 0.005 or 5 thousandths. Okay, we'll do this one. 8.4 times 10 to the negative 2. So again, write the decimal, alright, write the number between 1 and 10. Decimal's already there. We need to move it 2 times to the left. So we're going that way. So 1, 2 places. The 8 takes up one of those places. So we fill in with a 0 between it and the decimal. And then I rewrite it. 0.084. This 0 directly to the left is not 100% necessary. Alright, some people decide to write it, some people don't. This one right here is. It's a placeholder. It's separating, giving a space between the decimal and the 8, so we know that this is 84 thousandths. I put these last 2 down because these are the type that a lot of students will get wrong, even though, believe it or not, they're actually really easy. This first one is 4 times 10 to the 0. So what happens is this. I'm going to do the same steps I've been doing. The first thing I'm going to do, write down that number between 1 and 10. 4. Put a decimal after it. I look at the exponent to say, how many times do I move that decimal? I move it 0 times. I don't move it at all. So guess what? My answer is 4. So anytime I have a 10 to the 0 as my scientific notation, whatever number I have that's between 1 and 10, that's it. That's my answer. The other one is this. 5.33 times 10 to the 1. Same steps. 5.33. But again, what's it telling us to do? It's telling us to move that decimal 1 place. So I'll move it 1 place. So now I get it that the decimal is between the 2 3's. So I get 53.3. And realize, when I write something in scientific notation, it is perfectly possible to wind up still with the decimal with numbers after the decimal. That's okay. Alright? I hope this has been helpful. Remember, if you have questions, please feel free to message me and I will get back to you as soon as possible. Again, this is Mr. Oaks. Keep on keeping on. Bye.